Welcome to Chika Online Math.
Hello everyone, welcome to our second treatment on binomial theorem. That's the part 2 of binomial theorem. Okay, so in this example, we are asked to obtain the binomial expansion of 2x plus 3y raised to the power of 4. Okay, so we can use the combination method or the Pascal triangle. So let's use the Pascal triangle. We use the Pascal triangle to get the coefficients of the terms, okay, in the expansion. So we'll generate the Pascal triangle for n equal to 4. Okay, so let's start with the first one, n equal to 0. Okay, we have 1. Okay, for n equal to 1, we have 1, 1. Okay, for n equal to 2, we have what? 1, 2, 1. Okay, for n equal to 3, we have what? 1, 3, 3, 1. And for n equal to 4, we have what? 1, 4, 6, 4, 1. Okay, so these are the coefficients of the terms in the expansion. So let's do the expansion now. Okay, so we have 2x plus 3y raised to the power 4 equal to, we'll pick this first term 1. Okay, so we have 1, then we will now pick 2x. Okay, 2x raised to the power the n power, which is 4. Okay, then 3y raised to the power 0. Okay, plus, next we pick the second coefficient 4. Okay, so we have 4 into, then the power of 2x before is 4. So this time around it will decrease by 1. So we have 2x raised to the power 3. Okay, while the power of y of 3y will increase by 1. So from 0 it will jump to 3y raised to the power 1. Okay, plus the next term, the next coefficient is 6. Okay, so we have 6, then 2x, the power will decrease by 1. So from 3 it will jump down to 2. Okay, then 3y, the power will increase by 1. So from 1 it moves up to 2. Okay, then plus the next coefficient is 4. Okay, so we have 4 into the power of 2x will decrease by 1. Okay, while the power of 3y will increase by 1. Okay, plus we have the last coefficient, which is 1. Okay, 1, then 2x, from 1 the power will decrease to 0. Okay, then 3y, from 3 the power will increase to 4. Okay, so let's simplify. Okay, so 1, 2x raised to the power 4 is what? 2 raised to the power 4 is 16, then x raised to the power 4. Okay, then 3y raised to the power 0. Any number raised to the power 0 is 1. Okay, so we have 1 plus 4, then 2x raised to the power 3. 2 raised to the power 3 is 8, so x raised to the power 3. Okay, then 3y raised to the power 1 is still 3y. Okay, plus 6 into 2x raised to the power 2. So 2 raised to the power 2 is 4. Okay, then x raised to the power 2. Then 3y raised to the power 2. 3 raised to the power 2 is what? 9. Okay, then y raised to the power 2. Okay, plus 4 into 2x raised to the power 1 is what? Is 2x. Okay, then 3y raised to the power 3. 3 raised to the power 3 is what? 27. Then y raised to the power 3. Okay, plus 1 into 2x raised to the power 0. Any number raised to the power 0 is 1. Then 3y raised to the power 4. 3 raised to the power 4 is 81. So we have 81y raised to the power 4, okay? Which is equal to 1 times 16 times 1 is 16. So in the first term, we have 16x raised to the power 4, okay? Plus 4 times 8 is 32. Then 32 times 3 will give us what? 96. So we have 96. Then the variables are x raised to the power 3y, okay? Plus, then in the third term, we have 6 times 4, which is what? 24. And 24 times 9 will give us what? 216, right? So we have 216. Then the variables are x squared, y squared, okay? Then the next term, we have 4 times 2, which is 8. And 8 times 27 is what? Is still 216, okay? Then the variables are x, y raised to the power 3, okay? Plus, the last term is 1 times 1, which is 1. And 1 times 81 is still 1. It's still 81, okay? Y raised to the power 4, okay? So this is the expansion of 2x plus 3y raised to the power 4, okay? Now let's take the second example. Okay, in our example 2, we are to expand 1 minus 7x all raised to the power 3, okay? So see, we are given 1 minus 7x. This is the same thing as what? 1 plus minus 7x, because plus minus is minus, okay? So what this means is that if we should call this a plus b, then our a is 1 and our b is what? Minus 7x, okay? So that means 1 minus 7x raised to the power 3 equal to, okay? Now, we'll do Pascal triangle for n equal to 3. So the coefficients are 1, 3, 3, 1, okay? So for the first one, you pick the coefficient 1. So you have 1 into, then our a is 1. So 1 raised to the power n, and our n is 3, so raised to the power 3. Then b is minus 7x, starting from 0, okay? Plus, now, next, the second coefficient is 3, so we place it here. 3, then power of 1 will reduce by 1, while power of minus 7x will increase by 1, okay? Plus, the next coefficient is 3, so we have 3, then power of 1 will reduce by 1, and power of minus 7x will increase by 1, okay? Plus, the last coefficient, which is 1, power of 1 will reduce by 1, and power of minus 7x will increase by 1, giving you 3, okay? So this is equal to 1 times 1 raised to the power 3 is 1, and minus 7x raised to the power 0. Any number raised to the power 0 is what? 1, okay? Plus 3, then 1 square, 1 times 1, which is 1, minus 7x raised to the power 1 will give you the same minus 7x, okay? Plus, then 3, then 1 raised to the power 1 is what? 1. Then minus 7x raised to the power 2. What is minus 7 times minus 7? It's simply 49. Then x raised to the power 2, okay? Plus 1, then times 1 raised to the power 0 is 1, because any number raised to the power 0 is 1, okay? Then minus 7 raised to the power 3 is what? Minus 343, okay? Then we have our x raised to the power 3, okay? which is equal to 1 times 1 times 1 is 1, then 3 times 1 is 3, and 3 times minus 7 is what? Minus 21. Okay, then we'll bring down the variable x plus 3 times 1 is 3, and 3 times 49 is what? 147. Okay, then we'll bring down the variable x squared plus 1 times 1 is 1, and 1 times minus 343 is minus 343. So we have minus 343 here, then x raised to power 3. Okay, so this is the solution to the second example. So let's look at the third example. Okay, in our example 3, we are asked to find the first 5 terms in the expansion of x plus 3y to the power 20. Okay, so we'll start by recalling the binomial theory. Binomial theory, which states that a plus b to the power n equal to what? Summation r equal to 0 to n of what? N combination r, a to the power n minus r, and b to the power r. Okay, so in our case, we are given x plus 3y to the power 20. Okay, so if you compare, you see that our a is x, our b is 3y, and our n is 20. So if you substitute it in this binomial series, we have summation r equal to 0 to our n, which is 20, then 20 combination r, our a, which is x, to the power n, which is what? 20 minus r, our b, which is 3y, to the power r. Okay, so if you recall that in the question we're asked to find the first 5 terms. Okay, so we write out the first 5 terms. So we have, when r is 0, the first one is 20 combination 0 x to the power 20 minus r, which is 20, then 3y raised to power 0, because r is 0, and any number raised to power 0 is 1. So if we multiply it with this one, it's as good as not putting 1. Okay, then plus the second one is 20 combination 1 x to the power 20 minus 1, which is 19, then 3y to the power 1. Okay, plus the next one is 20 combination 2 x to the power 20 minus 2, which is 18, 3y to the power 2. Okay, plus the next one is 20 combination 3 x to the power 20 minus 3, which is 17, and 3y to the power 3. So we have 1, 2, 3, 4. So it remains the fifth term. That's for r equal to 4. That's 20 combination 4 x to the power 20 minus 4, which is 16, 3y to the power r, which is what? 4. Okay, so what is left is for us to evaluate the combination. So in doing that, we bring out our calculator. Okay, and we press 20 combination 0. Okay, so 20 combination 0 is 1. So we have equal to 1 times x raised to power 20 plus, then next we calculate 20 combination 1. Okay, so 20 combination 1 is 20. Okay, so we have 20 x raised to power 19 times 3y raised to power 1, which is 3y, plus, then next is 20 combination 2. Okay, so 20 combination 2 is 190. So we have 190 x raised to power 18, then 3y squared is what? 3 times 3, 9. So 9y squared, okay? Plus, then next is 20 combination 3, okay? And 20 combination 3 is 1140, okay? Then x raised to power 17, 3y all to power 3. And 3 raised to power 3 is what? 27. Okay, we have y raised to power 3, okay? Then the last one is 20 combination 4, okay? So if we press 20 combination 4 in the calculator, we have 4,845, okay? X raised to power 16, then 3y raised to power 4. 3 raised to power 4 is 3 times 3 times 3 times 3, which is what? 81, okay? Y raised to power 4, okay? So this is equal to 1 times x raised to power 20 is what? X raised to power 20 plus 20 times 3 is what? 60. So this is 60 x raised to power 19 y, okay? Plus, next, we have 190 times 9, okay? So we'll bring out our calculator. So 190 times 9 will give us 1710. So we have 1710 x raised to power 18 y raised to power 2, okay? Plus, next we have 1140 times 27, okay, for this multiplication. So it will give us 30,780. So we have 30780 x to the power 17 y to the power 3, okay? Then the last multiplication, we have 4,845 times 81, okay? So this gives us 392,445 x raised to power 16 y raised to power 4, okay? So this is our answer. So the first 5 terms of the expansion is what we just got as our final answer. So this is our final answer, okay, for our example 3, okay? So next we'll move over to example 4, okay? In our example 4, we are asked to find the coefficient of x raised to power 5 in the binomial expansion of 2 plus x raised to power 8, okay? So to start, we'll write the binomial expansion formula, okay, which is what? A plus b to power n equal to summation r equal to 0 to n combination r a to power n minus r b to power r. So 2 plus x to power 8, which means our a is 2, b is x, and n is 8. So if we substitute it in this series, we have summation r equal to 0 to n, which is 8, 8 combination r, a which is 2, so 2 to the power 8 minus r, b which is x to the power r, okay? So this is the expansion formula, okay? So what's the coefficient of x raised to power r in this expansion? So we see that the coefficient of x raised to power r is what? 8 combination r 2 to the power 8 minus r, okay? So we see that the coefficient of x raised to power 5 is what? When r is 5, so substitute r equal to 5 here. So we have what? 8 combination 5, 2 to the power 8 minus 5, okay? Which is what? 8 combination 5, 2 to the power 8 minus 5 is what? 3. And what is 8 combination 5? 8 combination 5 is 8 factorial all over 5 factorial times 8 minus 5 factorial, okay? And what is 2 to the power 3 is 8, okay? So this is equal to what? 8 factorial, which is what? 8 times 7 times 6 times 5 factorial all over 5 factorial times 3 factorial, okay? So 5 factorial will cancel 5 factorial, okay? Let's not forget the times 8 here, okay? Which is equal to what? 8 times 7 times 6 times 8. This 8, we'll bring it up here, all over what? 3 factorial. And what is our 3 factorial? 6, okay? So 6 will divide 6, okay? So what will remain will be what? 8 times 7 times 8. And what is 8 times 7 times 8? You agree with me that it's nothing but what? 448, okay? So the coefficient of s raised to the power 5 in the binomial expansion of 2 plus s raised to the power 8 is nothing but what? 448, okay? So that is the answer. So next we'll move over to example 5. Okay, in our example 5, we're asked to find the constant in the binomial expansion of x squared plus 1 over 3x, or raised to the power 12. Okay, so to solve this, we'll start by writing the binomial formula, which is what? A plus b to the power n equal to what? Summation r equal to 0 to n of what? N combination r, a to the power n minus r, and b to the power r, okay? Now, we are given what? We are given x squared plus 1 over 3x, okay? This is nothing but x squared plus what? 1 over 3x raised to the power minus 1, okay? Now, we'll substitute this into this series, okay? So we have what? S squared plus 1 over 3 s raised to the power minus 1 to the 12th power equal to, so if we compare this and this, we see that our a is s squared, our b is 1 over 3 s raised to the power minus 1, and our n is what? 12, okay? So if we substitute in this series, we have what? Summation r equal to 0 to n, which is 12. 12 combination r, our a, which is s squared, to the power 12 minus r, okay? Then b, which is what? 1 over 3 x raised to the power minus 1 to the power r, okay? So we use law of indices to combine these two. So we have summation r equal to 0 to n, 12 combination r, x to the power 2 into 12 minus r, and 1 over 3 to the power r, x to the power minus r, okay? Because minus 1 times r will give us minus r by law of indices, okay? So we have equal to summation r equal to 0 to our n, which is 12, okay? 1 over 3 to the power r 12 combination r x to the power 2 into 12 is what? 24 minus 2 into r is 2r, okay, times x to the power minus r, okay. So we can combine the powers of x further. So we have summation r equal to 0 to 12, 1 over 3 to the power r, 12 combination r. Now we combine the powers of x. So we have x raised to power 24, then minus 2r minus r will give us minus 3r, okay. Now remember the question says find the constant in the binomial expansion of this, okay. So the constant, what will make this value constant if you expand? The constant is when x is raising to the power 0, okay. So we want this number 24 minus 3r to be equal to 0, okay. So if 24 minus 3r equal to 0, then what does it tell us about r? So this means that 24 equal to 3r, okay. If you make r the subject, you have what? R is what? 24 over 3, which is what? 8. So if r is 8, then the expansion will give us, then that term will give us a constant term, okay. So, you know, the coefficient of x to the power 24 minus 3r is what? 1 over 3 raised to power r, 12 combination r, okay. Therefore, the constant is what? When r is equal to 8. So we have what? 1 over 3 raised to power 8, 12 combination 8, okay. So we'll use our calculator to evaluate 12 combination 8. So 12 combination 8 is 495, okay. So we have 1 over 3 raised to power 8. Now what is 3? So let's write 12 combination 8 first, the value. So this is 495, okay. Now what is 3 raised to power 8, okay. We can as well use the calculator. 3 to power 8 is 6561. So this is 1 over 6561, okay. So we'll be having the constant term as 495 all over 6561. So what can divide? So 9 can divide, okay. So if 9 divides the numerator, we have 55. And if 9 divides the denominator, what do we have? We have 729. Therefore, the constant term in that expansion is what? 55 over 729. That's the final answer, okay? So next, we'll do example 6. Okay, in example 6, we are asked to use the binomial theorem to evaluate 2.01 raised to power 4. Okay, so how do we achieve this? How do we use the binomial theorem to evaluate that? Okay, so to use binomial theorem to evaluate that, we'll write 2.01 raised to power 4 as what? 2 plus 0.01. Okay, then raised to power 4. Okay, so the Pascal's triangle coefficients are for n equal to 4, okay, because the Pascal triangle coefficient for n equal to 4 is 14641, okay. So if you substitute it here, you have the first coefficient, which is 1, So we have 1, 2 raised to the power 4 plus the next coefficient is 4. So we have 4, 2 raised to the power 3, then 0.01 raised to the power 1, okay? Plus the next coefficient is 6. So we have 6, 2 raised to the power 2, okay? 0.01 raised to the power 2, okay? Plus the next coefficient is 4, 4, 2 to the power 1, 0.01 raised to the power 3, plus the last coefficient is 1. So we have 1, 2 to the power 0. So we can remove that. Then 0.01 to the power 4. Okay? So this is equal to what? 1 times 2 to the power 4 is what? 16, plus the next one is 4 into 2 to the power 3 is what? 8. Then this one 0.01, okay, plus 6 into 2 to the power 2 is what? 4. Then 0.01 to the power 2 is what? 0.0001, okay, plus 4 times 2 to the power 1 is 2. 0.01 raised to the power 3 is what? 0.000001, okay, plus 1 times 0.01 raised to the power 4 is what? 0.00000001, okay? So this is nothing but what? 16 plus 32 times 0.01 is the same thing as 0.32 plus 6 times 4 is 24 times 0.0001 is what? 0.0024, okay, plus 4 times 2 is 8. 8 times this number is what? 0.000008, okay, plus the last one is 0.00000001, okay. So if you add this is very easy to add because the decimals, like 32, if you add, you have 322408, okay. Then this one is in the 8 digits, so 1 2 3 4 5 6 7 8, okay. So the answer is 16.32240801, okay. Next we'll do example 7. Okay, in our last example, example 7, we have to evaluate 0.98 all raised to the power 3 without the aid of a calculator. Okay. Okay, so to solve that, 0.98 raised to the power 3, we will write it as what? Instead of writing it as 0.0 plus 0.98, we'll write it as what? 1 minus 0.02, okay, because powers of 0.02 is easier to calculate instead of powers of 0.98, okay. So raised to power 3, okay. So this is the same thing as saying 1 plus minus 0.02 all raised to power 3, okay. So our A is like 1 and B is like minus 0.02, okay. We'll do the expansion using Pascal's triangle. So the coefficients are 1 3 3 1, okay. So this is equal to what? The first one, then this one raised to power 3, okay, minus 0.02 raised to power 0 is 1, so we omit it, plus the next coefficient is 3, then power of 1 will decrease by 1, while power of minus 0.02 will increase by 1, okay, plus next coefficient is 3, then power of 1 will decrease by 1, then minus 0.02 will raise to power 2, okay, plus, then the last coefficient is 1 raised to power 0 is 1, so we can write it or we omit it, then minus 0.02 raised to power 3, because the power will increase from 2 to 3, okay. So this is 1 times 1 plus 3 times 1. So 3 times 1 is 1. Then this one minus 0.02, okay? Plus 3 times 1 is 3. Then minus 0.02 raised to power 2 is what? 0.0004, okay? Plus 1 times minus 0.02 raised to power 3 is minus 0.02 raised to power 3, which is what? Minus 0.000008, okay. So this is nothing but what? 1 times 1 is 1, plus, then 3 times minus, so minus 3 times 0.02 is what? 0.06, okay, plus 3 times this one is what? 0.0012, okay, then minus 0.000008, okay. So to add the number, so what we have to do, we add the positive ones, then subtract the negative ones. So this will be what? If you add the positive, so you have what? 1 plus this one is what? 1.0012, minus, if you subtract the negative, which is this and this, you have what? Minus 0.060008, okay. So we'll do the subtraction and we get what? 0.941192, okay. So this final answer can be checked with the aid of a calculator, and we'll see that the answer is correct, okay. So I thank you for listening. I hope you enjoyed today's class. See you next time, okay.